Hello, in this video I'll be showing you two ways in which to derive Pythagoras' theorem from absolute scratch. Now, to derive his theorem from absolute scratch, we need to look at this diagram over here very carefully. First of all, let's focus on this largest square. It has a length a plus b and also a height a plus b. We know this because this length is a, and because this length is b, and also because this length is a, and because this length is b. Now the area of this largest square is going to be a plus b squared. Next, let's focus our attention on the lengths c, okay? And also the angle x plus y. Now the angle x plus y is equal to 90 degrees, okay? And because this length is c, and because this length is c, the area of this smaller square is going to be equal to c squared. Now in this diagram, you're also going to find rectangles. They have areas of a times b, which is length times height. Now, if you divide these rectangles into two, what you will find is right-angled triangles, and they have an area of half AB. Finally, let's turn our attention to this little square at the center of this diagram. It has a length b minus a, and also a height b minus a, which means that its area is b minus a squared. Now, I know that this length is b minus a because I have subtracted this length from b, okay, to get it. And the same can be said on this side. Now, thanks to the information I've just presented, we can derive Pythagoras' equation in two different ways. First of all, I'm going to say that a plus b squared, which is this length times this height, which is the area of this largest square, is equal to 4 times half AB, which is these four right-angled triangles, okay, plus c squared, which is this square in the middle of this diagram. Now, if I expand a plus b squared, I get a squared plus 2ab plus b squared. And this is equal to 4 times half ab, which is 2ab plus c squared. Now from here, if I subtract 2ab from both sides of this equation, what I end up with is a squared plus b squared is equal to c squared. And this is Pythagoras' theorem. Now I'm going to show you the second way to derive this theorem. We can say that c squared, which is the area of this square at the center of this diagram, is equal to 4 times half AB, which is these four right-angled triangles. Okay, 4 times half AB plus this little square in the middle, which is b minus a squared. Okay? Now, this over here is in fact 2ab plus b minus a squared, okay, which is 2ab plus, in brackets, b minus a squared. But what is b minus a squared? Well, it turns out that it is a plus b squared, which is the entire area of this square, minus 4ab, which is 4 of these rectangles, okay? So c squared is 2ab plus a plus b squared minus 4ab in brackets, okay? which is 2ab plus a squared plus 2ab plus b squared minus 4ab in brackets. Now this is 2ab plus, in brackets, a squared minus 2ab plus b squared, okay? Because 2ab minus 4ab is minus 2ab. And if I have 2ab minus 2ab, these two cancel out. And what I'm left with is a squared plus b squared, okay? And this is equal to c squared. So once again, I've derived Pythagoras' theorem. Now, if you have any questions related to this video, please leave your comments below. Thanks for watching this video.